Welcome back to our class ECE 3111 or Digital Electronics 1 for third year ECE students. Today we will learn the basics of logic gates. Okay, this is our first topic under logic gates. Now, um, at the end of this activity, the students will be able to identify the basics of logic symbols, okay, as what you have seen a while ago in our uh, front page. You will also learn how these logic symbols um, uses Boolean operator, and of course now you will also identify the part number of and the integrated circuit now based on its logic uh, name. And of course, now we are going to experiment on different types of logic gates. And then we will be combining logic gates to form a universal gates. Take note, for today's topic, we will only learn the basics, the three basic logic gates. Let's start with our previous topic. Now, during our previous topic, we have uh, studied about the binary numbers and decimal numbers and how we convert binary to decimal numbers. Now, we I want you to study this. I want you to go back now to this topic because these two are the most commonly used number system. Okay. Now, speaking of binary numbers, now we can represent a binary numbers, such as logic 0, or we can call it as binary 0, or for representation of logic 0 using an LED, it is actually an off LED. You can also represent logic 0 as false no, in Boolean expression. Also, for logic 1, we can also represent that as binary 1 or true, or we can represent that in the circuit as the on state LED. Now, here are three basic Boolean operation. When we say Boolean operation, it includes AND, OR, and NOT. When we say AND, now you are going to multiply two or more inputs. Now, in this example, I am using only two inputs for AND and OR and one for NOT. Of course, NOT gate will only have a single input. We call this NOT gate or inverter. Okay. In this topic, we will name this as NOT gate. Okay, now for an OR gate, this is actually the sum of the two inputs. When you recall, going back from your previous topic, when we say the sum of two binary numbers, when we say 1 plus 1 is still 1 in basic Boolean operation. So you have to remember that one. When we say NOT gate, that is actually the inverse or the invert of the inverted state of the input. When the input is 0, now the inverted state of 0 is equivalent to logic 1. So that's for the Boolean operation. Now, if we will relate the Boolean relations or operations into the equivalent logic symbols, okay, when we say AND gate, now this is actually, okay, right here is the symbol for AND gate. Okay, take note of this. This is the symbol for AND gate, where A and B are the inputs of your AND gate. So meaning to say, the output of your AND gate is just the product of your inputs. Okay. And for the OR gate, now it is represented by this symbol. Okay. So OR gate has two or more inputs. Okay. So in this example, I use two input OR gate. And so the output will just be the sum of the inputs. When you say 1 plus 1, the sum is still 1 in Boolean operations. Now for a NOT gate, now this is a symbol, this symbol, the symbol for NOT gate is actually a triangle with bubble at the end. So take note, triangle with bubble at the end, that is your NOT gate. So NOT gate meaning the inverted of your input will be your output. That's for the basic Boolean operations, no? Using the simplest, the three basic gates. Now, let's dig deeper on the AND gate. Now, this is the symbol for the AND gate, okay, as what we have discussed a while ago. Okay, the symbol for AND gate, and this is the Boolean operator. When we say Boolean operator, okay, this is actually A multiplied by P. So you can see here that that symbolizes multiplication. So you can write as A dot B, or you can write that as A B. So later on we will learn how to manipulate Boolean expression in our topic Boolean algebra. But in this example, I'm going to show you the truth table. So the truth table is actually a table of inputs and output. Okay, take note. So for inputs, now you have here input A and input B. And these are the possible combinations of the input. For example, if you have two inputs, there are four possible combinations, of your input. That is 0, 0, 0, 1, 1, 0, and 1, 1. So take note, for the number of possible combination is actually 2 raised to the number of inputs. So if number of input is 2, then 2 raised to 2 is equivalent to 4. That's the number of possible combinations. So take note of the Boolean operator. Now, that is just A multiplied by B. Now, if I'm going to multiply 0 and 0, the result will be 0. Multiply 0 and 1, the result will be 1. Now, that is in the truth table. If 1 multiplied by 0, the result is 0. Now, the output will only be 1 if both inputs are logic 1. As you can see here. Now, if you multiply 1 and 1, the result will be 1. That is the characteristic of your AND gate. So, for the AND gate, the output will only 1 if all inputs will be logic 1. Okay, that's for the AND gate. Now, let's discuss the OR gate. Now, for the OR gate, you have here A and B as the input and Y as your output. So here is the Boolean operator as what we have discussed a while ago. That is just A plus B. Now, if we will be creating a truth table here, the first thing that you should do is to create columns of these are the inputs and this will be your output. Now it so happens that there is only one output here, but it is also possible that you have multiple inputs and multiple outputs. That will be discussed later on once we reach combinational circuits. Okay, so we have here the Boolean operator A plus B. Take note of the Boolean operator or the function of OR gate. That is just adding two inputs. Okay, also A plus B is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 and 1 is equal to 1. That's the property of the OR gate. Meaning to say, now, if one or more input, now, if one or more input is in logic 1, the output will be logic 1 for the OR gate. The OR gate will only have an output of logic 0 if both inputs are at logic 0. Okay? That's the property of the OR gate. Now we go to the NOT gate. So the symbol for a NOT gate is a triangle with a bubble at the end. So bubble means you are going to invert. Okay? When you invert, you change 1 to 0 or you make 0 volts to 5 volts. That is the property of an inverting circuit. Okay? So for the Boolean operator, we have A complement. So we can call this A complement. Now in some other textbook, they call this as A bar. A bar. Okay? So I like to call this as A complement now in our class. So for the truth table, since you have only one input, so as I have said a while ago, the number of possible input is 2 raised to the number of inputs. So in this case, the number of input is 1, 2 raised to 1 is 2. There are 2 possible inputs. So if you have 2 possible inputs, of course you also have 2 possible outputs. That is 0 and 1 only. Okay? Of course, the output will always be 2 possible states. That is 0 or 1. Since you have only one output. Now, for the Boolean inputs of 0, okay, the complement of that is logic 1. As well as if you have the input of 1, the complement for that is 0. That is how the NOT gate works. Okay. Now, these are the 3 basic logic gates, symbols, and the IC um, part number. Okay. So, for an AND gate, now we call this as 7408. Now we will learn all the characters here. No? Like for example, SN74HC08N. Take note, we will learn what are these symbols once we reach integrated circuits. Later part, no, that will be in the later part of our lesson. But for now, no, we will just study the part number that is 7408. It means that is an AND gate. For 7432, it means that is an OR gate. So this is an OR gate, this is an AND gate, and this is a NOT gate. 7404. So this is very famous gate, the NOT gate. Okay. Okay, that's it for the 3 basic logic gates. Of course, no, there are how many logic gates? 7. So you have um, NOR gate, you have NAND gate, XNOR, and XOR gate. So we will discuss that once we reach combinational circuits. Okay. Now we go to the part number 7408. 7408 is an AND gate IC. Now what you see here in the arrow, this is your uh, this is a hole that indicates that you have this pin as pin number 1. So the hole here actually um, marks pin number 1. So pin number 1, 2, 3 going into counterclockwise direction. So meaning to say, now if this is pin number 1, now 1, 2, 3, 4, 5, 6, 7, 8 until you reach pin number 14 in counterclockwise direction. Now we call this one here, we call this as your notch. Notch. So meaning when we say notch, no? So meaning to say sometimes the IC have no hole. So if you have the notch here, no? So for the viewer's view, no, the notch now on the left side of the notch, no, that is in your view, you have here your pin number 1. So later on we will discuss that. Now, so inside the AND gate IC or the 7408 IC, you have 4 AND gates. So you have 4 AND gates, meaning to say the first AND gate, the inputs are from 1 and 2, pins number 1 and 2, and the output is at pin number 3. Take note, your IC should have also power. You have to connect this to a power supply. So pin number 7 and pin number 14 should be connected to the power supply. So pin 14 is the positive 5 volts, pin 7 is the negative 5 volts. What will happen if you reverse the polarity? Okay, it might destroy your IC. No. You are lucky if the IC will not be destroyed once you connected it in a reverse manner. So be careful when connecting your integrated circuit IC, especially the BCC and the ground. Okay. Now let's have an experiment. Let's experiment AND gate now. So in this circuit, now I will explain the circuit. I have here, the first part here is the power supply. Now you have designed this now back in your hands-on laboratory number 1. So for the power supply, now this is a simple power supply since it is only powering one IC. It doesn't have to be a big power supply. This is a simple power supply, 7805, meaning to say the output is 5 volts. Now, so if the output is 5 volts, definitely your input should be greater than 5 volts. So 5 volts is the regulated output. 5 volts will be connected to the VCC of your IC, and the ground will be connected to the ground of your IC at pin number 7. So you can see here now the numbers 1 and 2, that's the number now in your IC, the input of the first AND gate, 1 and 2, and the output is 3. So if you will notice here, LEDs are connected to the inputs to indicate that the input is logic 1 or logic 0. You will see that later on. So the resistors here are just current limiting resistors that will limit the current that passes your LED. Okay. Same is true with LED number 3, but this one will serve as your output, okay, LED. Okay, and this will be also be the current limiting resistor. Okay, current limiting resistor is very important so that the LED will not be destroyed once high current will pass through it. So the resistor will limit the current passing through your LED. So you are going to connect this now in your breadboard. But if you don't have a breadboard, you can just use Tinkercad now for now. Okay, this is the breadboard diagram. So in my breadboard diagram, I have here the space for my 9-volt battery. This is the terminal for the 9-volt battery that is connected to 7805. So 7805, pin number 3 is 5 volts. That's connected to the positive line here on your breadboard. So negative will be this line. Okay, I think now you can see the positive and negative terminals here. So A and B LED are actually used for inputs. It will actually illuminate now when the input is logic 1. So it is off. Now it will turn off if the input is in logic 0. So we will try that later on. Okay. Now our first diagram here. Now we have inputs 0, 0 as indicated by the lines, yellow connectors here that is connected to the ground. So if the yellow lines are connected to the ground, both the LEDs now will be turned off. That indicates that the input of A and B are all logic 0. Since this is an AND gate, logic 0 multiplied by logic 0 is also logic 0. Okay, take note of that. And let's try this one. What if now we are going to change the input? Instead, now we will have the input B as logic 1 and input A will be logic 0. So this LED indicates that A is in logic 0, B is in logic 1. In the truth table you have 0, 1, then the output is still off, that is logic 0. So because if you multiply the input, 0 times 1, that is still 0. Okay, now going back, so if LED A is turned on, B is turned off, that is equivalent to 1, 0, the output will still be 0. Move on. If all inputs are logic 1, that is 1, 1, then the output will be logic 1 also. So that's the property of the AND gate. Okay, you have to do that in your Tinkercad or your real IC 7408. Okay, now let's discuss the OR gate IC So as I have said a while ago, you have here the hole, which indicates that this pin is pin number 1. Going on clockwise direction, until we reach this pin, this will be pin number 14. Okay, so pin number 7 is here. Now take note of the, uh, this is the standard connection for IC. Most of the IC, BCC, and ground are connected to the corners. 14 will be the BCC, 7 will be the ground, pin 7. So a look at let's take a look at the internals of your 7432. So the internals of 7432, so you can see here now you have four. This is not an AND gate. This is an OR gate. So you have to change this one. This is an OR gate. So let's change this one first. Okay, erase. Oh, sorry for that. This is an OR gate. So typographical error. Sorry for that. So we'll move on. Let's move on. So this is an OR gate, meaning to say, now the input for an OR gate, now for the first OR gate, you have pin number 1 and pin number 2. And the output will be pin number 3. Take note of the orientation of the inputs and output, because later on you will be using multiple OR gates or multiple IC inside, multiple gates inside your IC. Take note of the orientation. So you can see this in the data sheets of your IC. That is why, as an engineering student, you need to read data sheets of your integrated circuit or any electronics component. You have to read that. Okay. Now, since now we will be experimenting the OR gate. Okay, this is now the simple experiment schematic diagram for the OR gate. Now, we actually just changed the IC part number here. This time, this is 7432. Now, the connection is still the same with the previous circuit, but this is now your 7432. I will not be explaining this, or the role of each elements here. Now, it is obvious that LEDs here will indicate the inputs, whether it is high or low, or the output LED will indicate that the output is high or low also. Let's proceed now with the experiment of the OR gate. So as you can see here, both A and B are logic 0 because it is not turning on. Okay, so meaning to say, if both inputs are logic 0, that is 0, 0, and the output will also be 0. That's for the OR gate. Now, if one of the input is logic 1, just like this one, B is in logic 1, the output is 1. Now let's go to the next circuit, next input, I mean. And this time A is a logic 1 and B is 0. This is 1, 0, and the output is 1. This time, next one will be both inputs are in logic 1. So therefore, the output will also be logic 1. Okay, that's the property of your OR gate. So if any of the inputs are logic 1, the output will be logic 1 also. Okay, that's for the OR gate. Okay, now what is this IC? Now this is not again typographical error. Okay, I will erase this part. This time we are now in NOT gate. So in NOT gate, this is the pin configuration. We have pin 1, near the notch, as indicated by the hole. 7 and 14 are for ground and BCC respectively. Now let's take a look at the internals of your NOT gate. Take note, this is your NOT gate. Okay. NOT gate. Okay, so the NOT gate has one input and one output. So take note of the orientation of the pins of the gate. That is very important. Now, if you will connect inputs, no, input to this pin, no, it will destroy uh, the IC. So it might destroy this uh, IC. So don't do that. So try to review first before powering on your logic circuit. Okay, now this is the NOT gate experiment schematic. This is very simple. You only have one LED as the input and one LED as the output. The resistors are for current limiting ability. Now, so take note of the symbol. Now, we will be using pin 1 and pin 2 as we will be using this NOT gate connected to pin 1 and pin 2. Okay, now let's try this one. We will connect and then we will power on the gate. Now, initially, now this is connected to the ground. That is why the LED here, the input LED is turned off. Once the input is turned off, since this is a NOT gate, the output will be logic 1. It will turn on the LED in the output if the input is in logic 0. The same is true with if the input is logic 1 as indicated by the LED, the output becomes logic 0. That's how NOT gate works. Okay, now for your hands-on activity. Now we will be combining. Okay, I'm sorry. We will be combining two gates. Like for example, if we will combine the OR gate and the NOT gate, you will result to NOR gate. NOR means not or. Okay, NOR means not or. So the symbol for not or for NOR gate is an OR gate with a bubble no, at the output. So take note of that. An OR gate with a bubble in the output is a NOR gate. Same is true with and NOT. So the symbol for NAND is an AND gate with a bubble at the output. So bubble output. Okay. So that is now the equivalent gate. Now these are the combinational gates and this is the equivalent gate. So what you will do here is you will be connecting two IC, that is the OR gate and the NOT gate. And then later on you will try to use the IC, the NOR gate IC, which is 7402. Now that's the part number. 7402 is the NOR gate. So you are going to demo how this gate and this gate works. So you are going to create a circuit side by side with this combinational gate and the equivalent gate. That is the uh, activity that you will do, as well as this activity and this activity. So you will use logically to simulate this combinational gate and the equivalent NOR gate. So take note, logically makes it easier now to simulate logic gates. Okay, but in your demonstration video, you are going to use the real IC. So if you have a real IC, a real logic gates IC, then you can use it. If not, we will be using Tinkercad. Okay, so as to simulate the demonstration of the gate. So the details of that hands-on activity is in your Canvas course. Okay, so that's it for today, and now we will be discussing universal gates in our next meeting. So thank you, and I hope you've learned something today. Goodbye.